gonna bump up. Ooh. Boy, this is heavy. No, it's not. Well, good afternoon, everybody. So today we're going to be taking a look at EG4's newest battery, their 100 amp hour wall mount battery. Let's take a look at the specs of the battery. We're going to pop the hood and see what's inside. We'll run a capacity test, and then we'll see how does it pair with the 6000 XP. So this is a 48 volt nominal, 5.12 kilowatt hour lithium iron phosphate battery. It can handle up to 100 amps of charging or discharging. It has high and low temperature protection built in. And this battery does have a built-in 100 amp BMS, which utilizes the EG4 protocol. It has two 150 amp bus bars built into the top of this, similar to their other wall mount style batteries, which allow you to parallel multiple batteries together. This does come with a 10-year warranty, and the cells inside this are supposed to be rated for 6,000 cycles down to 80% depth of discharge. So if you cycled this battery from 100% down to 0 6,000 times, you would still have 80% capacity left in this battery. So this is an indoor rated battery. It's IP20 rated. It does have a couple UL certifications, UL 1973 and then UL 9540A. And so, I'm kind of excited because this is my first actual EG4 battery to take a look at, play around with. So I get to see in person how they actually do. So when I brought this battery in, I made it seem like it was heavy. It's not any heavier than a server rack battery. I think it's 108 pounds. Dimensions on it, including the feet up to the top of the post on top of the battery, you're at 25 inches. Width-wise, you're at 18. Depth, including the mounting bracket on the back, which we'll see in a second, is about 7.5 inches. So taking a look at the front of the battery, they do have a color informational display, which details the BMS version, the state of the battery, the voltage, the current, the state of charge, and then the date and time. 4 different control buttons, an alarm, run, and state of charge indicator. And then they also have their traditional EG4 logo on the front. On the right-hand side of the battery, they have the BMS on and off switch, 125 amp nadir breaker with a shunt trip built into it, statistics and serial number, basic warnings, and then I like how they built the handle directly into the side of the battery itself. Those spring-loaded handles, while they're nice, sometimes they just don't give you a good grip, where this is actually built up into the case itself, and your fingers can go pretty far up to get a good grip on both sides. The other side of the battery just has the hand grip. It doesn't have anything else on it. And the back side of the battery does have a removable bracket, which does allow you to not only hang it on the wall, but lock the battery onto the bracket using 4 screws, 2 on each side. And on the bottom, there are 4 non-adjustable rubber feet that can be removed with a Phillips screwdriver. And onto the business end of the battery, starting from left to right. On the bottom left, there is a grounding stud. We have 2 positive connections with a Degson connector. These 2 are our battery communication ports. This does have RS-485 and CAN communication capability to communicate with a handful of different BMSs. We have a reset button right here, our ID dip switches for identifying the battery. You can daisy chain up to, I believe it's 64 in parallel. And then we have our negative battery terminals, again with the Degson quick connect connectors. And then around the outside of the top of this battery, there are 4 raised screws. And these 4 raised screws are actually removable so that you can add on a conduit box specifically for the 100 amp hour battery. And it's supposed to marry the 100 amp hour battery to the EG4 6000 XP. So we'll take a look at that here in a little bit as well. And inside the box, obviously, you get the 100 amp hour wall mount battery. You do get a positive and negative battery cables. One end has the Degson connector on one side. The other side doesn't have anything terminated right now, and that's for both of them. And this is 4 gauge, 105 degrees Celsius cables, and they're about 5 feet long. We have a quality control report. We have a Cat 6 cable that's 1.5 meters or just about 5 feet. And then we have a bag of anchors for the wall mount battery itself. Since EG4 talks about this being paired with the 6000 XP, they also say that it can be easily paired with the 3000. It would be nice if they included a set of battery lugs for the 4 gauge wire. They don't have to put it on the cables themselves, because if you want to use it with the EG4 3000 inverter, that does not take battery lugs. So I guess my recommendation would be to throw a pair of 4 gauge lugs into the bag, so that if you're going to use it for the 6000 XP, all you got to do is crimp them on. So let's pop the top on this thing and see if it looks as good on the inside as it does on the outside. So I removed all the screws from the outside. Then as I get ready to open this up, I just have to remind you, don't do this at home. I'm a trained professional. I know what I'm doing. No, I'm not. And no, I don't. Just don't do it. It will void your warranty if you do open these up. So let's take a peek at what's under the hood. Ooh, pretty. So right off the top, if we look at the cover, we do have 2 fire arresters built into the lid. I do like seeing these long ribbon cables so that if you do have to open up the battery, it makes it easier to put the lid off to the side. And then taking a peek here, it's just nice seeing well thought out designs in batteries. I mean, I've opened up a handful of batteries, and it's just, when somebody takes pride in designing things, it just, you can tell. All right, so this is a 16S configuration. Main positive is right here. Main negative is right here. We have, it's like Phillips screws. It's interesting to see a Phillips head there, though. But there is a laser weld marker on the outside, so they just really wanted to make sure that these bus bars weren't going anywhere. Anyways, where was I? We do have marks on each connection point signifying that it has been checked. We see our different balance leads. They are screwed directly down to the bus bar, and they have some of the silicone goop to keep it from moving. We have several temperature sensors placed on top of the bus bars, which I love to see, and they are in different locations across the battery itself. So I see one here, 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 and here. And that's just for the cells. Usually there's at least one down here on the BMS somewhere, so we could be looking at 5 or 6 different temperature sensors. They have the cells in what look to be like a plastic shell used to help fixture everything and give proper spacing, because this is all one piece for this side of the battery. And then this side is in its own, so it's almost like they're modules. So you've got one module of 8 cells over here and one module of 8 cells right here. None of the vents are covered up, which is good to see. I also love to see that the QR codes for the cells are easily visible. So we'll have to get a snapshot of one of those here and check that here in a second. Coming over here to kind of the brains of this battery. So we've got our power switch for our BMS, our circuit breaker and shunt trip right here. Our main positive line coming off the battery, it says 200 degrees Celsius. And looking at the negative, it's 4-gauge wire, 4-gauge silicone wire. Still lots of flex in it. It's not actually tensioned. Coming off the top of the circuit breaker, we have a pair of 8-gauge wires coming up to this bus bar plate, which is connected to our Degson connectors. And we've got our main negative coming down to the BMS, and then our BMS leads actually go down underneath the BMS on that side. There's lots of room in here coming up to the top here. This has to be like the brains of the communication board, because it's got all of the ribbon cables coming off of it for the different communication aspects. So you've got the one ribbon going up to your display. You also have another ribbon coming over to your communication port board. And then down at the bottom, it looks like there's actually a little buck converter. Can you see it? That can't be a buck converter, can it? No. I don't know what that is. So that the lines off of that come up right here onto the BMS. So yeah, I actually don't know what that is down there. So if you do, please, by all means, let me know. And we've got our BMS, which is kind of neat seeing the BMS in a protective, underneath a protective case, or protective cover. So yeah, pretty nice looking battery here. One thing that I would like to see with some of these batteries that have these terminals facing up is just some kind of a cover to separate and isolate this metal top piece from the terminals of the cells. Because one accidental bump, somebody hits a battery too hard for whatever reason, and that lid gets pressed in, it could easily create a short across some of these. Now, these rails should help prevent some of that, but it all depends on where it ends up getting hit. So just, one thing that I would like to see on some more of these batteries is just a isolating cover just in case. Paste our code in. ETC battery cells, 3.2 nominal voltage. Production date November 29th, 2024. I'm not familiar with ETC cells, but I guess we'll find out how well they do, won't we? Let's take a look at the display on the battery here. So if I press the power button on the BMS on the side, you can see all the lights boot up, and then our display becomes active. So we can see that it's currently in a standby state, voltage 52.72 volts, zero current, and we're at 52% state of charge. Press the enter button and you can see the individual cell voltages. And if you press this button, the enter button again, you'll see the temperature voltages. So we've got 1, 2, 3, 4 temperature sensors. So those are the ones that we saw. And then there is one built onto the BMS PCB. And we can go back to home, If we press the back button, we can see that the protocol is currently set to EG4 on the RS485 and EG4/Lux Power for the CAN port. We can see the BMS version and the LCD version. All right, so we'll get ready to do a capacity test here. So we've got a 100 amp hour battery, so we're going to be looking to do a 20 amp discharge. It's going to take about 5 hours to do that. So we'll see if we get a full 100 amp hour discharge out of the EG4 battery, or can we get, maybe 105 amp hours out of the battery? I don't know, but we're going to find out together. And I will say, there are pros and cons to having these Degson connectors on top. I mean, it is nice being able to just grab the connector, push it down, and lock it in. But the downside is that means that you have to have a Degson connector for whatever you're trying to connect. So there's pros and cons for both having it and not having it. But man, it is nice just being able to just say, oh yeah, here, let me put this on. Okay, I'm done. Don't need any tools, nothing. So we've got this wired into my test wall. We'll use the Victron Smart Shunt to take care of our calculation for our full discharge. And as always, we'll be taking the charge inverter and dumping the power into my main battery bank because I don't like wasting that power. So let's turn on the charge inverter. And I don't know if you'll be able to hear the scream startup of the charge inverter. Looking at the test wall, we're currently drawing 18 amps, 19 amps, 20 amps. And it levels out at about 20 amps right on the nose. So we've got about 5 hours of running. So we'll be back when the test completes and see how she does. Well, the capacity test on the EG4 battery finished up last night around midnight. You see up here in the top right hand corner we have 99 amp hours. And the battery says that it is at 1%, which leads me to believe that a little more could get eked out. That voltage, what you're seeing, is what's being read off of my power supply. But yeah, 99 amp hours out of the listed 100 amp hours. State of charge is 1%, but the BMS is turned off. So almost there. Does power back on, 50.48 volts and 0% state of charge. If we look at the cells, 3.1, 3.1, so they all look fairly similar. I was talking to Will in a previous video and he mentioned that he would like to see the discharge curve on some of these tests. And so during this test, I hooked the VRM up so that it could get the snapshots from the Smart Shunt and be able to chart that curve. So there we go. There's our discharge curve. Just before 7:30, we started the test, and we had a steep drop to basically our flat level area with a 20 amp discharge, and we ended, at least the last snapshot that the VRM got was 44.94 volts with 22.7 amps. While I'm waiting for this to just settle after charging again before I run another capacity test, I did receive the conduit box for this battery, and so I figure I can just go ahead and throw everything together. And so it does come nice packaged. I have messed all that up right now, so it's not even worth kind of showing you, but it will give it just that nice look as I scratch everything up. But yeah, I mean, these are the push screws that they need on all the inverters, so you can't lose them. Anyways, This does have a knockout on top, which I'm not going to mess with right now. We've got all the different gland sizes. And it is a nice touch that they give you the closable ones in case you do end up opening one of these up and you don't need it. And it looks like these pass-through gaskets. They give you the right sizes for the 6000 XP. And then you've got your thumb screw faceplate. But yeah, that looks nice. And it's near flush with the front of the battery. Proper width for the side. I like it. Now I just have to figure out how to get the 6000 XP to stand by itself. If I had any request to make about this specific buildable battery box, the only thing that comes to mind is if there could be a plate or some kind of cover back here. You see my fingers are coming up through the back, just to keep bugs out. I mean, because depending on if you're putting your batteries and stuff in a shed, or even in my basement, you know, spiders like to find these little nooks and crannies and stuff. And so if I could just have something here just to keep it almost completely closed, just to keep the bugs out, that would be nice. But other than that, I like it. It's not that complicated even for me to put together. Without instructions, it just may take you a few extra minutes to do it. So after I got the conduit box all put together, it looks like the knockouts on the left side and the right side don't match. Now, that's really not a big deal if you're only using one wall mount battery, but if you're looking to parallel multiples together, then the larger knockouts won't line up. The 3/4 inch ones still do. So I made EG4 aware of this, and they're working on resolving the issue. The 100 amp hour wall mount battery is designed to work together with either the 6000 XP or the EG4 3000 inverter. So we're gonna just quickly connect this up to our 6000 XP on the bench here. Make our battery connections, get them all nice and tight. Take our communication wire, plug it into the battery communication port over here. Now with our one battery, the ID, the manual is a little confusing. And typically, I would think that on is up. But in this case, you need to have the first pin down and all the rest of them up to be ID 1. So it's almost like the on is where the number is, not where it says on. And we'll take our battery connections. You know, the other nice thing I like about these is they only fit on the one size. Negative doesn't fit on positive, so you can't mix them up accidentally, even if you're not paying attention to the colors. So we've got everything connected up. Proper startup procedure is to close the breaker on the inverter first. So turn it on. We'll then close the breaker on the battery. And then turn the BMS on. The lights will start to light up. That'll do its pre-charge sequence. And now the inverter should have power. So when we turn on the switch, everything boots up like normal. If by chance your inverter is not sent to the proper protocol, press and hold to enter. To go into the menu, you'll hit up 3 times to get to your battery settings. Hit enter. You want the type to be lithium ion and brand to be 0. Then you can back out. So you can see 100% state of charge, 100 amp hours on our battery. Nice and simple. And one other thing that you need to do with this specific battery, if you're using it on the 6000 XP, is go back into the settings. You need to limit the current which is option 9. And by default, it's 140 amps. I believe these Degson connectors can only handle up to 120. So if you're putting multiples in parallel, have it 120. If you're doing one battery, you do 100 amps. And then you would hit enter and back out. And you can also make those changes on the EG4 monitoring site. I'm not sure if you can actually do it from the mobile app. I don't think so. That might be one of those settings that you can't do from the mobile app. So I did end up running the capacity test on this battery 2 more times. And both of those times I did end up reaching the rated 100 amp hour capacity. Now, full disclosure, during both of those tests, I had some issues where my inverter kept resetting its low disconnect voltage level. So it would end up hitting like 50 volts, and then my discharge test would stop, and it ended up sitting that way for about a half an hour, 45 minutes each time. So the battery had plenty of time to spring back up to its resting voltage. And then once I found out, I reset the test again, and it hit that 100 amp hour discharge. So I think that kind of points out that even during my 20 amp discharge test the first time, and I hit that 99 amp hour level, had I restarted it, I would have easily been able to get over 100 amp hours. So I'm going to be honest. When I first saw that EG4 was coming out with a 100 amp hour wall mount battery, I thought, why? What's the point? You've got the 100 amp hour server rack batteries, you've got the indoor wall mount battery, you've got the outdoor wall mount battery. So why build this? And I'm sure I wasn't the only one to think that. When you compare this to the, I think it's the LL-S model, all the specs are virtually the same. Same certifications, display, remote shutdown options, capacity, all those things are the same. The only differences that I have seen, besides the obvious form factor, is this has the 150 amp bus bar built in. The cycle rating for this is only 6,000 cycles versus the LL-S is 7,000 cycles. But that's really it. Those are the only differences that I can see between the two. As far as the pricing differences between the wall mount and the server rack battery, I think there's like a $150 difference. And again, my first thought was, why is it higher than the server rack battery? And then I started just looking at it closer, and you know, it does have the wall mount ability with the bracket. It's got the ability to easily add the conduit box on top. It's got the Degson quick connectors. Do all those add up to $150? Maybe. So, you know, I guess I can see the rationale for the price difference being a little bit higher, since this is more of a standalone style battery than I guess the traditional server rack style would be. And so I was mulling over trying to figure out, you know, what would be some use cases for this. Keep in mind that it's, you know, designed to seamlessly integrate with the EG4 3000 or the 6000 XP. And so I thought maybe, you know, a small cabin that doesn't need a whole lot of power, one 6000 XP and a 100 amp hour battery. It could easily get tucked off into the corner. It can still look nice, having the integrated conduit box with it. You could also do those popular cart builds, the dolly builds. And I think that the wall mount battery actually might have a leg up versus just taking and popping a server rack battery on a dolly. Let me show you why I think that, but I have to warn you, I'm going to be using some super fancy techniques here for demonstration. Some high quality work here. So here's my fancy server rack battery. The EG4 LL model. So keep in mind, when you've got your server rack batteries, there's always going to be a required orientation that you're allowed to put this battery in. You can lay it on, its sides. You can lay it on the bottom. You can put it on its back, but you can't put it face down where the EG4 logo is. And the reason is because you've got your cells point up. And so you can't place it to where the cells are facing down. Does that make sense? So for a cart build, somebody's going to take their battery, and if it has a display on it, usually you're going to want to be able to look at the display while it's mounted to the cart, right? So you'll have it in this orientation. From the LL model, you'll have the logo facing to the back of the cart. Now here's the problem that I see with that. Anytime you go to move this cart, you're tipping it back in the direction that the battery is not supposed to be. And if you have to load this into a vehicle, a truck, to move it, and you can't leave it standing up, you're laying your cart down flat. And your battery is now completely upside down in the orientation that it is not supposed to be in. Cell vents and terminals facing down. If somebody was consciously thinking about the cell orientation when they're moving the battery around, yes, they could mount it like this, but then your display becomes extremely hard to read. Now we look at the 100 amp hour battery. The terminals and the vents for the cells are facing this cover, which you're never going to put it in an orientation to where this side is down. So you can always see your display, your cells are facing in the proper direction, and you can safely lay your cart down and not have to worry about damaging the cells inside your battery. And another bonus, if you have the conduit box with the 6000 XP, all your wires are completely covered inside. But even if you don't have the conduit box, you still have completely safe battery connections, free from anything accidentally touching the bare terminal. So yeah, you could have a pretty nice cart build. I guess one last place that I could see this being used for is possibly in an RV build. It would be better than the server rack batteries because usually those RV compartments are pretty small and tight, and you could actually mount the bracket on the back to the floor of the RV and then lock the battery into the bracket, keeps it from moving, shifting, any of that stuff. And because those spaces are so tight, you're not having to fight with a 300-pound wall mount battery. You're only having to move a 100-pound one. So just some thoughts, ideas. I guess, what are your guys' thoughts? What did you think when they came out with this battery? Do you see any other use cases that I'm not seeing yet? In your own installations, would you put a 100 amp hour server rack battery or a 100 amp hour wall mount battery? I know that from the footprint, they each have different use cases. I do want to thank Signature Solar for sending this out for me to take a look at. It's my first EG4 battery to take a look at. So I was kind of excited to, see what I've only seen so far in videos from everybody else. I'll leave links down in the description for the wall mount battery, the conduit box. I did purchase the conduit box with my own money, by the way, but Signature Solar did send me this battery. I do have a discount code down there. If you spend more than $500, then you can get $50 off. I'll leave that information in the description below because there's a time limit on the code. Lots of stuff, but lots of new things continually coming out from EG4, which is always exciting to see new products coming out into the solar market. So with that, I'm gonna let y'all go. Y'all stay safe. I guess I have to stop saying stay warm because it's starting to warm up, huh? Stay safe, stay cool, and we'll catch up with you later.